Hello, and welcome to 5 Minutes of Postgres. My name is Lucas, and today we're going to talk about tracing Postgres locks using eBPF programs. This is a post by Jan from Timescale2B team, and here describes two projects that he started over the holiday break, which help you utilize eBPF programs in Linux to get additional statistics from Postgres that are not accessible otherwise. This only works when you're running Postgres on your own virtual machine, but it is pretty cool, and I think it shows some promise of how to use eBPF for monitoring Postgres. First of all, Jan introduced a tool called pganalyze. pganalyze is inspired in spirit by what the pglocks table shows you, which is which locks are currently held by which Postgres connection. However, the difference here is that pganalyze looks at every single locking invocation and summarizes them over time. Obviously, this has some overhead, so this is not necessarily something you would run on your production system all the time, but this actually might make sense if you are facing issues that you can't debug otherwise. Generally speaking, an eBPF program or a Berkeley packet filter program is running inside Linux, essentially a way to have low-level analysis functionality that is running through the kernel and is able to look at activity on the system or in particular processes. What pganalyze does is it looks at statistics about taken locks, like the number of locks, the lock types, and the delay for acquiring the lock. As Jan describes here, this is intended for developers or sysadmins that want to get additional information about the internals of Postgres. And I think a good audience for this is the people that would usually run perf on a Linux VM, which you can use to see which part of Postgres is busy if you're running Postgres on your own VM. This goes beyond just showing the stack trace, but giving you information on which lock is being held. Now you can install this using pip the Python package manager, and you also need the BPF tools installed, which are required to compile the kernel-specific eBPF program. You then execute the tracer against your Postgres installation, and it needs to know the location of your Postgres binary, as well as be able to make a connection to the database. You can issue a query, like creating a table, and then what the tracer outputs is which activity is happening behind the scenes when you're doing this create table. You can see here, as part of Postgres creating a table, it will actually look at various internal catalog tables. This is a short version of all the different activity. This can help you understand what Postgres is doing behind the scenes. At the end, the tracer outputs a summary statistic like this. This can be helpful to then say, for example, that most of the locks taken were on this pgcatalog pgdepend reference index relation and how long it took to get that lock. You can also see the lock types like an access share lock or row exclusive lock or access exclusive lock. Again, this might help you if your system is very busy and you're trying to understand which locks are being held or which locks are being acquired. What's the busy part? This can help you discover that. Another thing that Jan created was PGLWLocks. Postgres, there's two different lock types. There's lightweight locks, which are used internally in Postgres, and heavyweight locks, which we just looked at. PGLWLocks is for tracing lightweight locks. This can be helpful if you want to go beyond the weight event sampling that a lot of tools do today. And this will let you look at the individual blocks that are being held inside Postgres. LWLocks uses the USDT trace points in Postgres. These are specific trace points that are predefined in Postgres source code, and you can then hook into, for example, with a BPF program. You have to have compiled Postgres with the enable-dtrace option. For historic reasons, this is referred to as dtrace, but really these days you would call this USDT probes. If you have compiled it with that, you can use the BPF trace program to list out these trace points in the Postgres binary. And really what you're interested in is that this shows you trace points because it shows that Postgres was compiled with the right settings. After you've done that, you can install a pglwlocks, and this, again, similar to the other program, will show you how LW locks are being acquired. And these are very fast, short locks, right? We're talking about internal locks like the buffer manager and things like if different processes try to insert the wall, Postgres has a lightweight lock that is used for that. This is something that I would be even more careful with when running an actual production system because there is a little bit of overhead to looking at these probes. But again, if you have a production situation and you're looking for more information, this may be of use for that. Now here again, we have statistics and we can see how many LW locks were acquired over time and which function was used inside Postgres to acquire these. That may also help you understand when there is contention, is it waiting on this lock a lot? and that is then slowing down your queries. Quite useful information that's otherwise impossible to get if you have your own virtual machine and you're already using tools like perf. This seems like a great addition to your tool belt. On GitHub, you can find the pglocktracer as well as the PGLWLocks project. I think it's really great to see more folks trying out the eBPF programs, especially combining that with monitoring Postgres. Thanks so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel, hear about next week's episode, and talk to you next week.